Good morning, good afternoon, everyone. Hopefully you can hear me all right. And I'm going to pull up our slides for today. I've been sitting quietly and typing and taking a look at the slides. Now I need a drink of water. But appreciate everybody joining me today for just a quick presentation on a few thoughts about having a successful career. And yes, the paper that I provided at RANS last year, which was on basically the same topic, successful career in reliability engineering, is the basis for today's presentation. And it's something I'm coming back to over and over again as I look at how to work with different people, so the basic idea of any career and any pursuit of a business or passion or a career or a job or a function that we provide for other people, whether for ourselves or within a larger setting, say within a business or organization, is that we're often provided a range of different opportunities. You know, going to school opens some doors, taking classes opens some doors, working with a really good team opens some new doors. But then how do we manage that as we go through life? And when I look back at my own career, I couldn't have planned it. It seems to have been opportunistic, and chances came my way, and I took advantage of those. I didn't always have great foresight that it would turn into a great career. I have been very, very fortunate in many ways that way. But I've also seen in a couple of other articles and some research when I wrote this paper, there's certain things we can do to help us create a successful career. And that's the basis for what I wanted to talk about today. So before I get too far into that, I wanted to ask, how did you get into reliability engineering or an engineering field, say if you're related to reliability in some form or another? I know that, and if you can use the chat window, just let me know, were you formally trained? Did you go get a master's, or maybe your undergraduate degree had a reliability program? Or did you get tapped on the shoulder like I did and said, hey, we want you to investigate this problem? And that became an area of expertise for you, whether it was statistics or designing a test or, so got one that's Sue Quinn. I'm sure I'm not pronouncing that right. Never studied reliability. So how did you get into reliability? How did you find this interesting? I know my own story was my boss said, hey, I've got this heating cable, this little product that we want to, a customer wants to make sure it lasts for 20 years. Go figure it out. And so started opening books and asking questions and did my first accelerated life test. Yep, got assigned, same as me. Graduated a double E, and I found early in my own career, I was working as a design for manufacturing engineer, that a combination of the statistics and trying to make arguments to improve products, that if I was working on yield, say in a production process, as a high volume product, it wasn't always enough of an advantage. But when I said it reduces the field failure rate and it saves us warranty, it started to make more sense. So between running accelerated testing and being expected to do more of the reliability work as I did more, I also found it to be really useful as an argument to make product improvements. So it became part of what I would do. Yeah, Rajesh put into the reliability team, probably the best thing that ever happened. But I find that a good number of people are assigned or tapped on the shoulder And it's a role that often has to be done, but it's not always one that we think of as we work forward into it. And I wouldn't say that there's any one way to get into it. And I found that it's often that blend of education, whether it's formal, going through a master's program, or working through a series of seminars and workshops and classes to hone your skills, or all on the job. And oftentimes it's a mix of those two things that gives you the ability to say, this is something I really enjoy, and I want to look for and take more opportunities in this area. And that creates a career. And that's, I imagine, true whether you're an electrical engineer designing analog circuits, or if you're an industrial designer looking at the way a product will look as it's packaged or it's presented to customers. Or machine tooling is what's useful and what's durable enough and so on. If you find something you're interested in and you're good at it, it's a pretty good signal, a way to build a career. So I'm looking at it as it's in many regards, people fall into it one way or the other. Some have more foresight and make it work, and others change as they go along. And I'm seeing quite a few of the comments that's, tapped into it, or volunteered into it, or started to learn it as you went along. And that's very, very common. So let me back up a little bit and tell you a story that some of you may have heard. I recognize a handful of people on the line, and so I apologize if you've heard this story. But years ago, I had the opportunity to do a reliability assessment, and it was very similar products, and there was two divisions inside Hewlett-Packard, and one was upstairs and one was downstairs from each other in a fairly large complex of buildings at one of the HP sites. They both made a small circuit card, essentially, that provided internet connectivity for other products. So it was sold to other parts of the divisions. And they had slightly different focuses. One was consumers, one was commercial. And so they were slightly different technology, but very, very similar products. Both organizations had a reliability professional on staff and had left about a year and a half, 2 years prior to me arriving. Both organizations were still in business. They were about the same size of business. And I was doing a sweep of assessments all across the company to take a look at what people did to achieve the results they were getting. We also had, internally, we had access to the warranty information and field failure rate information. So we had a sense that the upstairs group was pretty good. They had very, very low failure rates in the field. They had very high customer satisfaction and all those indicators. Downstairs, from the numbers, they were a complete mess. They had very high failure rates. They had a huge customer dissatisfaction. They were losing market share, even with internal to the company customers. Other divisions were going to a third party to get that part rather than internally. And so there was an opportunity, by chance that they were co-located, to look at both organizations pretty much within 2 days. And the way the scheduling worked is I was going up and down the stairs between interviews. It just kind of worked out as I started upstairs. And I enjoyed a really nice cup of coffee, had a great conversation with an electrical engineer. She knew what the reliability objectives were. She knew how to do accelerated testing. She says, when I need to do it, when there's sufficient need to know. We work pretty closely together to understand our customers. And I said, but you don't have a reliability professional. She said, well, I know what I need to do. and I understand the other people's roles. It's just built into our product development cycle. It's just what we do. Okay, that's interesting. And upstairs it was calm. It was very, very enjoyable. Then I went downstairs. Coffee was bad. It had been, I think, left over from the day before. Every meeting started late. There was a lot of noise. People were called into immediate meetings to deal with a new customer failure or customer situation. And when I finally got to talk to a handful of people there, they said, well, you're talking about reliability stuff. And we used to do that. We had this guy, Jeff, he was assigned here and he did all that stuff. He did the rating analysis, he did the product testing, he did the reliability estimates and modeling. He did all of the elements that you're asking about, but we don't do that anymore. We don't have time. We're dealing with all the field failures and customer complaints. Well, then I go back upstairs and thinking, well, what's the difference? Why did this happen? Why did upstairs embed the reliability activities within their organization? And it was a Mabel was her name. She was, I think, originally from Puerto Rico. And she, like many of us on the session, learned reliability because her boss asked her to at some point. And she picked it up as she went along. And she had left the organization to move to another division closer to home for, I think, where her grandchildren were. But the people that I talked to, and then later talked to Mabel, was the basic idea of her approach was that she was a coach. She was a mentor. She provided the connections and the tools to the rest of the team so that they could do it. And it was the attitude of it was a part of their job. And when she left, she was very happy and confident that the organization would continue, and they did. Whereas downstairs, Jeff did everything himself and was learning like Mabel. He was also a relatively experienced person, but he didn't turn that corner to help other people. He just did it and thought that was sufficient. And while he was there, a lot of things happened, but he didn't quite have the amount of influence. And so I ran into Jeff years later and asked him about that experience. And that was his last role in reliability, and he said it was so frustrating because nobody listened to me. Would say this is going to have a high failure rate and show them the evidence, and they'd chip it anyway. And he said, so I left in frustration. And it was from that 2 days of interviews going back and forth, and then later talking to these two reliability engineers about their approach that made me think about my own career in reliability. And it made me sit back and think, well, how did that happen? Why was there such a difference? And I had some evidence in between those two groups, upstairs and downstairs. But it was really put in focus what we do as reliability engineers and how we do our job. So I want to pull up just ask you a question here. Let's go back to the chat window. And so what's success for you? If I want to talk about a successful career, I gave two stories there about two different organizations and how a reliability engineer influenced or didn't. But that's not necessarily success, upstairs or downstairs. That might not be how they defined it. How would you define success for your career? Oh, and Colleen, I see you back in. Is the audio working for you while we're going here? Takes responsibility to make things happen. Yeah, Sergio, yeah. Certification, CRE, yeah, that's a good one. Contribution is valuable and you're sought after. I know in some organizations, Jeff, that one of the rationale for promotions, especially on a technical ladder, is that others seek you out for your talent and information. Enjoy. Zuquin, I agree. I've long thought that I enjoy what I'm doing and therefore I'm successful. I imagine that I could enjoy a lot of different kinds of work and jobs. But I'm digging a little deeper in what drives it, what makes it work for you. Do things you love. Yeah, I totally agree. Making a difference. Yeah. So I'm seeing, a couple of things from external, like the CRE or event or an award, but mostly I'm seeing internal types of success factors. And it doesn't, there's no right answer for this, right? When you look at other people and what makes them successful, maybe they're looking for that corner office and the promotion. Maybe they're looking for a pay raise. That's fine. Maybe they're looking for the fulfillment, and that Norma had mentioned. Making a difference, other things like that, making a difference in the world, making products more reliable. That has an intrinsic kind of reward to it. So for some people, and as many of you mentioned, it's retired safe. It's a personal accomplishment. It's fulfillment, making a difference, making products better, improving customer satisfaction. In some regard, that's good for the organization. It's good for your career. But I think people that are motivated intrinsically are motivated by doing a good job in and of themselves. You might call it inner joy, you might not, but it comes from within. Is you know that you did a good job. And as we work with our peers and our colleagues, not everybody has that same motivation. Sometimes they're motivated by recognition and awards. So acknowledging the contribution of other people, giving them a pat on the back or a certificate or an award or a medal, or for some people, they're working for the satisfaction of getting a pay raise or having a secure retirement or having authority or power from their position. It's personal. It's how you get satisfaction from what you're doing. So there's no right or wrong way to define what is success over the long term, and it's up to you individually to do that. Being aware of that, though, and being aware of what motivates other people can help you in your own career. So as you are working with, say, your design team or your plant maintenance team, what is it that they need to derive success or the sense of satisfaction from their work? And it's a mix. I'm quite sure it is. And so as you think through your own career, what drives you, but also think about what works with other people. All right. Thanks for the input there. There's lots of different ways to go at this. So let's talk about, I think I've got a total of 8 different attributes or elements that I've identified through a variety of different thinking about this and some other papers and other works about what it takes to get a successful career. One is the awareness of what is success, but the other one is you got to know what you're doing. I think it was Jeff or somebody else mentioned getting the CRE certification. It's a milestone. It demonstrates that you have mastered a body of knowledge. As other people seek you out and as you make a difference in the world, it's through your talent oftentimes. Do you know the statistics? Did you design an appropriate life test that made resulted in good information? Can you lead an FMEA that actually creates improvements to the product? things like that, failure analysis skills and techniques and so on. One of the things I really like about reliability engineering is it doesn't change very fast. We get new materials, we get new equipment, we get new technologies that we apply the same tools to. What could fail and how will it fail? But it's mastering the reliability statistics is a strength for some. Mastering environmental testing is a strength for some. Mastering one or two areas that you're the expert is a good way to go. Being familiar with all the rest of it and how they fit together is another way to look at talent. So let's take a look at, and I'm going to pull up two chat windows here. So talent has lots of different meanings for lots of different people. I kind of outlined a quick view there. Do you have any examples of what would be the lack of talent? Put those on the right. And how about somebody that has great talent? What's an example of that? How would you recognize that? And let's put that on the left. Yep, I think I still have some chats from the last time around. So what's an example of a lack of talent? Faster results. Tim, what do you mean by that? What is it? And it's on the lack of talent side. What? Oh, still from the last time. Yeah, just recycle the results. Yeah, I agree, Jeff. Not understanding the concepts. Yeah, blame. Yeah. To err is human, to blame somebody else is more human, was a quote I saw the other day, Sergio. That's right on line with that. Yeah. So Brian, you're on the good side. You know, framing decisions. That reminds me, one of my earlier managers, Judy Glazier, was phenomenal at doing that. I thought she was absolutely brilliant. She would ask, what you're working on or and I would always tell her about something I was stuck and I was struggling with. And she wouldn't answer the question. She wouldn't tell me an answer, and she might have known, but she helped me see it in a different way. She'd ask me one or two questions or say, well, what about when you look at it this way? And then an answer would be clear. She was brilliant at doing that. She was very, very talented. Yeah, good action. Yeah, Victor, very good. So I wanted to do this because it's one of those intangibles. It's a talent is roughly defined as that you're good at something. Well, what does that mean, right? To some, it means they're thoughtful, they're precise, they're accurate, they provide value with their contributions. And the lack of that would be an example of no talent. And we probably have plenty of examples from our own experiences. Rajesh, giving reliability figures, as many of you know my opinion on MTBF, it's usually something I would think about is asking, so what do you mean by this figure of, I saw it yesterday, 40,000 hours MTBF? What do you mean? And this was, of course, for a fan with a bearing wear out problem. All right, good, thank you. Let me go back to the slides here. So another aspect to consider is being professional. There's a couple of formal definitions of profession or professional, but one of it is that we have a body of knowledge. And what I don't mean by being professional is using our profession's language, using terms and definitions that only reliability professionals understand. It's sort of like the medical industry uses a whole slew of medical terminology in Latin, basically, and I have no idea what they're saying. I don't think that's professional. I think that's, well, lots of other things other than professional. But part of our role is to be able to explain and articulate our positions, our recommendations, our results from the work we do in a confident way. We know what we're talking about. And one of the studies I ran into as I was doing background work for this paper was that one of the best ways to be confident is to be confident. Is stand up, look them in the eye, use a firm voice, talk about your work and so on, like you know what you're talking about. It's kind of ironic that you can fake yourself into being confident. But when I step back from that, part of the realm about presenting is that you present out loud. You talk into a mirror, or you find a willing subject to listen to your presentation as you go through it. And you want to stand up tall, you want to breathe slowly, you want to be calm, and that helps you to come across as professional. And especially in our business settings, that often is what people judge us on, is our body language to a large extent. It's more than that, though. So part of it is having the talent, knowing what we're talking about, doing the homework, knowing what we're presenting, actually having the evidence to be confident. Then on top of it is to be confident. It's one of the pieces of advice I ran into through one of the psychology papers, is that you, by your voice tone, by your body posture, you convey confidence. And as people recognize that, they respect it, and that builds your confidence. And sure, you have to be able to answer questions on your material. That's talent. So the other piece I ran into here is calm, is take a deep breath, slow down. That helps a tremendous amount to convey a professional persona. And it helps you feel better too, as you get more oxygen to your brain. You have the resources to think. And those are parts of this process. The other definition of professional is that there's a code of ethics, essentially. So mechanical engineers, civil engineers, professional engineers, even ASQ for quality and reliability professionals, we have codes of conduct or codes of ethics. And it means that we're working using our expertise for the betterment of society in the larger context. Yes, we derive personal satisfaction and success from that, and it's open and honest. It's not on the sly. We're not making recommendations that are for our sole benefit, things like that. So hopefully that should be obvious. But if we do our job, and as many of you mentioned when I asked about what's success, this is part and parcel to it, is we work to help our team, our organization, improve products, have customers have a better experience with our products, and so on. And I would say that that's all part of being professional. Another, and this changes the subject completely, is networked. And this is a snapshot, and I don't remember how I got this. I saw some link somewhere that says, see a map of your network. And this is a picture from within LinkedIn of my connections. And it's how they're connected to each other. So this group way over on the right there is my college friends. And they've gone off into all kinds of different areas of the world, and very few are in reliability. So they're kind of separate. And I believe the top group up here are people I know from my rock climbing adventures and hobbies type stuff. But the vast majority of the people I know are in or connected to engineering and product development, plant maintenance, and connected to me through the work of my profession, reliability engineering. Now, I don't expect everybody to have a LinkedIn map that looks like this. Yet, in general, you should have a strong network. It's long been advocated that you need a strong network if you need to find work, or if you want to help somebody else find work. Being well connected certainly helps. But I don't work at being connected to other people for that reason. I do it because there's so many smart people in the world that have answers to questions that I have. What's the melt point for this particular polymer? Well, in my network, I know somebody at DuPont that knows the right person to answer that question, or could help me find the data sheet, as a quick example. The other part is that I can also listen to what other people are asking questions about and answer it for them and provide answers. I tend to have subscribed years and years ago to the idea of answering 5 questions for every one I ask. And the idea is to build up a bank of goodwill, and hopefully that's working. But that's what I think of as a network, is that we're all in this together. And oftentimes, as a reliability professional, it's rare that we're working on a larger team of other reliability professionals. There might be one person in your organization, you, that does what you do. But whether it's through LinkedIn or other avenues for connecting, is you find support, you find knowledge, you find camaraderie with other people like what we do, as other reliability professionals. So I pull a lot of value and strength out of the network and the people I associate with. And so that's why I included this. But I've also found that it works in a long career, especially intrinsically. It's the friends you make. It's the people you know that really help you define whether you're being successful or not. And so you can work at it, stay in touch with people. I remember a few years ago I had a program that would remind me, saying, hey, you haven't talked to Bill in over a year, say hello. And it would just prompt me to touch base with people, to stay in touch. And so being networked is a key, in my mind, to a successful career. If nothing else, it'll help you find answers to questions faster. I think that's a good thing. Another attribute I want to touch on briefly is positive. And I listed the subtitle really as Pursue Goals, but this is really on the notion of the glass is half full or the glass is half empty kind of concept, is attitude as you approach the world. And I'm going to pause just for a second. I have to change my battery in my headset. Okay. The notion of positive, and I saw in the chat window, a lot of us were talking about providing value, supporting other people, making a difference, things like that. Part of that approach is that you can. There's the Henry Ford quote was floating around on LinkedIn and other sites the last couple of weeks, is that if you think you can or you think you can't, you're right, basically. And I'm paraphrasing. And the notion is that if you think you can't do it, you put a negative spin on it, and you then reinforce that concept by seeing all the barriers and all the hurdles and all the obstacles. You hear all the naysayers. Whereas and it takes discipline. It's not 100% all the time, but by framing it as, I can do that, I can get that accelerated test done, and I can get good results for that. And I can learn what the failure mechanism is and how it models to an acceleration factor. I can do that. It helps me see the information that allows me to solve that problem. It allows me to hear the promoters, the supporters that are encouraging me to find the right answer. So it's in my mind, it's a big thing, yet it's something that you should have under your own control. It takes practice. So when I first started practicing how to pursue larger goals, and I was struggling with a lot of hearing all of the obstacles here and all the problems that were occurring, it was that manager, Judy, that said, well, let's look at it this way. What does it look like when you actually have accomplished the goal? When you've gotten over the bridge, gotten through the fog? What does it look like over there? And this is the Golden Gate Bridge, and it looks like Marin. There's Marin Headlands and that area, and I could picture it. And the goal that I was pursuing in this discussion with Judy. And then I look back at all those hurdles, and I could see ways to solve them. But the trick that she taught me was that by starting with the end in mind, I think it's Stephen Covey and others have recommended this as you set up goals, is what does it look like when you're done? How do you know you've accomplished your goal? And by creating a positive image of the result, it allows you to see a path to accomplishing it. You're not faced with nothing but the hurdles. So it's an interesting thing that we ourselves control, and it allows us to filter the rest of the world such that we can see and pursue the goals that are important to us. So hopefully the font's coming across better than what I'm seeing here. It looks like Mentor got cut off here, but these are 4 more areas that I want to talk about briefly, and I'm going to take a look at the questions part. Yeah, Gene, School of Hard Knocks is, I think there's a series of quotes going around LinkedIn in particular that it has more of a spin for entrepreneurs that, failure is not permanent and success is not final. But if you can learn from your failures, whether we're designing a new product and we're doing halt testing, we certainly want to learn from those failures of what we're finding in our lab or in the prototype evaluations of our products so that our customers don't see it. But the same applies to our careers. As we bounce through life and experiences and working with all kinds of different people and situations, yeah, sometimes we're not successful. Can you learn from that? That's really the key piece of that part of it. And Norma, I'm not sure what the comment means, a reliability class in master class plus a job in reliability. If you could elaborate on that a little bit, I have an idea what you're talking about, but I'm not exactly sure. So if there's any other questions, please do use the Q&A tab or the chat window and fire a few things off. That'd be great. So I think it was 2 months ago I talked about value. How do we add value and identify value that we add as a reliability professional? And I don't know that I brought that link with me. And Neil, you're not seeing all the chats. Well, the Q&A I think is just isolated. I'm not sure of how to set that up to show to everybody. Thanks, Norma. Yeah, Neil, I'll have to figure out that setting to get all of the questions to show up. I'll have to sort out a way to do that. So one of the things we do, whether it's in the reliability engineering career or profession, or in most any other ones, is that we tend to work to add value. Does it make a difference? How do we quantify that? And so I'm using this kind of banker looking guy in front of which is, I think, is a picture of a bank or some ornate kind of doors here. But the idea is that if we're going to do an accelerated life test and come up with an estimate for durability of a product, if nobody uses that result to make a decision, is it worth doing? One example I ran into years ago is Elizabeth did just phenomenal work on doing halt testing. She would take prototypes from a couple of different divisions in the organization and would run it through the halt testing. She would invite the engineers, who rarely showed up, but they would get a very detailed report with really detailed failure analysis and recommendations of what to do about it. And so I followed one of those reports to the person she sent it to and noticed they were stacked up next to the door. I had a whole pile of reports from the last few years, but had never read them. And he said, well, she breaks them, but she uses way too much stress. And so it's not useful to me. So if you're familiar with halt testing, which I imagine many of you are, well, that's the purpose, right? And is to force it to fail and find out what actually fails first, and provides that insight as to what failure mechanisms are likely to fail over time in your product. It's not of any value if the product doesn't make any improvements based on that information. And it's the same in our career. If we're the reliability engineer, it's like that engineer, if I remember, Jeff downstairs, in my story of upstairs, downstairs. He did a lot of work, and he was frustrated because very few people were using it. He didn't take the time to help other people understand why it was useful. That could have been part of the problem, I don't know for sure. But he was not seeing the value of his contribution, nor were his peers. And upstairs, Mabel worked to help people understand the value of understanding the reliability tools and tasks, when and why to do specific things. And so they took it on themselves to make it happen because it was useful for their role, for their job. There's a lot more on value, and I know that I've got it recorded, so if you missed the presentation from a couple months ago, Finding Value webinar, and if I remember, I'll put a link up at the end of today's presentation of where that is. But there's a lot of ways we can calculate value. It helps us when we want to make a proposal or make a presentation. It also helps us personally to understand the contribution that we've made. So if you do an FMEA or a HALT and you find this critical failure mechanism that the team solves and doesn't allow to ship with the product, or it makes a major improvement to a piece of equipment such that you improve the uptime, you can directly calculate the value of that, of the cost avoidance, of the savings that were done with that. The change in failure rate alone, with the knowledge of what's the cost per failure, it's a simple calculation. So that's part of it. I find that by calculating value, it reinforces the work that you do is on the most useful things. But more importantly, it allows you to tell other people the value that you've contributed. And it helps with buy-in, it helps with acceptance, it helps with people taking action on it, those kinds of things. So look for how you connect to the rest of the business, the rest of the organization, in terms that are important to them. It's a key piece is that. So and I mentioned a couple of them, but let me pull up a larger chat window. What are sources of value that you look for in your organization? Where do you draw value, and how do you talk about it? How do you quantify it? And the one I'll give you is you reduce the failure rate of your device or your system. And if you know the cost of failures, you can calculate it directly. What are some other sources that you tap into? Avoiding rework. Yeah, Jeff, in my work in doing a lot of assessments, I typically ask how much engineering talent is used working on field failures or on product failures. And it's averages about 25% of engineering talent in organizations are used to deal with fielded products when they fail. That's a lot of talent in some organizations. Yeah. Time to solution, Tim, you're exactly right. And that's an example of halt testing. If I can find the failure mechanism early, it's like in software testing. Don't wait till all the code is finished. Start testing modules of it and blocks of it. Look for those bugs early and often. Give the team a fighting chance to solve it before everything gets locked down. Yeah, there's this basic idea that if you find it earlier, it's less expensive to fix it. And I had a librarian try to track down the source of that. And I haven't been able to find any hard evidence that's been published. It was used in a book in the 80s that was used in a course to teach people at NASA. So the slides became public, but the source of the statement was not. So I think it was anecdotal to start with. Yet I know in practice in organizations, the cost of changing something after it goes to the field, say the GM experience, is exceedingly expensive. Where if they would have changed it in the design before it was released, had they known about it appropriately and made aware of it, it may have cost them $100,000 to make the change, but it's nothing compared to what they're paying now. So anecdotally, I think many of us can have examples of that. It's how do you quantify it in your own organization, though? And that might take a little bit more work. Yeah, best practices, agree, Victor. Find value, we can prioritize that, working on the right things. That sure does make a difference. Yeah, I agree. All right, thanks. So let me talk about, and I realized this as I was reviewing the slides, these books are upside down. They're not intended to be read, and they're not on reliability, but I'm kind of interested in what they are about, what language even. Obviously a stock photo. And I noticed at the start that a handful of people came into reliability by a master's degree or going through school to become a reliability engineer. And many of us were tapped on the shoulder and said, hey, poof, you're the reliability guy now. Go figure this out. We learned it one way or the other, whether it was through other people, through classes, seminars, workshops, reading books, whatever. That doesn't stop. I think one of the keys to success is probably better phrased as the curiosity. Is willing to ask questions and to learn something and be open-minded to learn something. There's so many opportunities we have now, whether it's seminars and webinars like this one, or online classes, or going back to school, or just talking to those other brilliant people that we work with and asking them about how do you think about this problem? That's a source of learning in being a student. I'm drawing a blank on the name of it. It's The Artist Way. That's the name of it. The Artist Way at Work is a phenomenal book. It's, I think, 20 or so years old now, but I open it up every now and then and go back through some of the things they talk about. And one of the recommendations to spark your imagination, your inventiveness, your effectiveness at doing your work, is to take time every week to learn something. It doesn't have to be specifically job related, but if you're interested in, say, pottery, go learn about pottery. Spend some time at a potter shop and how do they actually do this and what are the characteristics of the clay and so on. Be curious about other professions or other works or other ways of doing things. Is that curiosity itself, the ability to learn, then translates back to your primary work and your job, and it gives you a fresh perspective, another way of looking at things. And of course, if you run into a new material, it's the same kind of curiosity is, well, how does it work? What happens when I heat it up? What happens if it's under stress? What are the ways it can fail? One of the things I like about what we do as reliability engineers is we get to make things break. We break things. And we learn an amazing amount all the time by doing that. So part of it is the formal learning. Part of it is just the inquisitiveness is a key element. And then there's a phrase or a saying that the best way to learn something is to try to teach it. I fully subscribe to that. Years and years ago, my boss said, we need to know more about statistical process control. I was working in a factory, and he said, you're going to teach a class on this next month. So I don't know anything about that. And he says, well, teaching the class will fix that. Yeah, he's so right. And so I was learning it, a day prior to the sequence of classes that he had me doing, but I learned so much at doing that. So part of what we do as a reliability engineer is explaining what is and is not MTBF, for example, or what is and is not the failure mechanism, how it manifests itself in this particular product or system. We can teach by one-on-one discussions with our peers, by writing about it, blogging, sharing on our network, and contributing, say, to a webinar. By the way, if you'd like to do a webinar, let me know. We'll get you on the Ascendio webinar series. But thinking through and how do you explain it to somebody helps cement that knowledge in your own way. So it's like learning, yet it's just, in my mind, it's another form of learning. But it also connects back into those other success factors of networking and providing value. And it may provide both internal, intrinsic, or extrinsic rewards for you. You might like doing a great presentation and the applause, and you may find success in the connections it allows you to have and being recognized as an expert, or just being able to do it very well and helping other people make good decisions. Those are all ways to derive success out of teaching. So in closing, back when I was at Hewlett-Packard, which I saw my anniversary showed up at my 10th anniversary from leaving HP and being a consultant. It was about 10 years ago. So prior to that, for about 5 years, I was working in a corporate office as a reliability engineer in a small team that's provided internal consulting to the rest of the organization. My predecessor, Dick Moss, had been doing a similar role in quality and reliability at the corporate offices for close to 30 years. And he's a co-author on one of the Handbook of Reliability Engineering and Management, and co-editor, I should say, and contributed quite a bit of the material to that book. So I had the chance to overlap with him for about a year or two, and then even after he retired, we would get together for lunch regularly. And it was on one of those lunches that when we go for a walk, I asked him, so you've been retired for what, a year now or so, do you miss it at all? And he goes, oh yeah, I miss it. I don't miss coming into the office every day and the rigor of that. I like my retirement and freedom. I get to do all these other things I'm interested in. But I said, well, what do you miss? And he said, I miss the ability to make a difference. And I said, what do you mean? And he said, and I knew that he had taught many, many courses on design for reliability and reliability engineering practices to managers and engineers all across the corporation. He said, remember the last year that I was there, I went on like a world tour. I went to all of the different sites in Hewlett-Packard. And I got to meet a lot of people I knew over the years, plus new people. And they would listen and learn and take notes. And he said, and it was a farewell tour. He knew he was retiring, and he would mention that. And he said so many people he did not know, came up and shook his hand and said thanks. That the work he had done had made such a difference in their career, in their products, for their customers, and so on. But so many of them were personally improve their careers and professions because of the work that Dick had done to help them be a better engineer. And he said, that's what I miss, is the ability to really help other people be as good as they can be. And so his success really was that internal or intrinsic value of making a difference and doing a good job and helping other people. He was a natural at it. And he had found his stride, his profession, and found a successful way to have a wonderful career. And his impact was, in my mind, amazing, absolutely profound. But he took so much joy from that it's a way to look back at your career. So one of the ideas here is that as we work on a day-to-day basis, it's keep that end in mind. It's what is it that is successful for us? And what is it we're looking for? What is it that is the recognition that we want when we retire or when we step back from our working life and our professional career? And then today, look for those opportunities and windows of fortune that allow us to step towards achieving that success. So whether it's exercising your network and teaching, or working through getting promotions and finding value for your organization or for your customers, whatever it is, keeping that in mind is, what do you want to know? What's important to you as you retire, as you look back, and then take steps today to make that happen. So to be a successful reliability professional does take work, dedication, learning, experience, great network, all of these things. Yet it's within all of our grasp to do. And so hopefully today's discussion provides just a handful of different ways to give you ways to think about how can you craft and build your career as you move forward. So that's mostly what hopefully it comes across as. Whether we were given the opportunity as an assignment or we've created the opportunity ourselves, we can do it. And so that's the end of what I wanted to bring across. So I'll take a look, see if there's any questions or so on. I'm seeing a couple of things pop up in the chat window. Good, Kyle. Yeah, reliability statistics is one of those that it seems very few people master and understand. So that the danger is if you know a little bit, you become the expert, and then you got to really get to know it. So yeah, there's plenty of material out there. The creprep.wordpress.com is a great site for lots of tutorials, mini tutorials on reliability statistical elements and terms. So more online training, Kyle. One of the things, and I'm trying to think if I have it up on the list here, over on the right, there's links for more information. There's a reliability engineering webinar list, and I send out a monthly compilation of all of the webinars that are related to reliability engineering that I can find. And I think last month there was like 15 or 16 different webinars. Sign up for that list. It comes out once a month, and it gives you a sense of what's coming up, and most of them are free, not all of them. The other place is the reliabilitycalendar.org, and it lists, I think there's something like 1,500 classes, webinars, seminars, conferences, meetings, items like that. And it provides a vast range of different ways to pick up stuff, and some are online, some aren't. About 2 weeks ago, we just started the University of Maryland Reliability Engineering and Management course, and that this year is all online. And if you stay in touch with me, I can tell you about other courses that I'll be offering online, both CRE prep through the local ASQ section, and our engineering management, reliability engineering management course that I expect to start in about 2-3 weeks. So if you're interested in that, just send me an email and I'll let you know more about it. So how do you engage management? You know, Victor, the easiest thing that I found was you got to put it in terms of what's important to management. So where I first ran into it was we're making products at Hewlett Packard, and it was field failure rates warranty. If we could change the failure rates, and it cost us, and I had to talk to some finance people to find out what the cost of failure was. If we could change it by a small percentage, we would save these millions of dollars. That got their attention. It was a bigger savings than most anything else. And the example that I was working on was a procurement engineer wanted to change a component to a higher failure rate component, and it cost less. So he would save a nickel, but cost us 25 cents per product, for example, in warranty costs. So my proposal showed that math and said, when we consider the cost of failure, this is not a good cost savings. So the procurement team was not happy with me. The management team was. Now I could have said, this is just a change in reliability and it's getting worse, that's not good. That comes across pretty flat to most management teams. So it's put it in terms they understand. That's the easiest thing. I appreciate all the thanks, and I'm working on setting this up on a monthly basis, and hopefully more often if I get the opportunity to do it. I'm looking for other speakers. I've got a handful of in the line. I've got a few more talks myself that I want to do. So hopefully the format and engagement works out for you. Appreciate all the feedback.